Hello and welcome to another exciting chemistry section. So we're still in the series of mole concept, and as of today we're going to look at what we call calculation of moles using elementary entities. Calculation of moles using elementary entities. So when we are talking about elementary entities, we are talking about particles, we are talking about atoms, we're talking about molecules, ions, electrons, protons, and neutrons. So we are going to look at a relationship between moles and elementary entities. And this was a study that was done by a scientist by the name of Avogadro, a scientist called Avogadro. So Avogadro stated that one mole of a substance contains as many elementary entities as there are in exactly 12 grams of carbon 12. This simply means that one mole of an element or one mole of an atom comprises or contains 6.02 times 10 to the power 23 of these elementary entities. And the number 6.02 times 10 to the power 23 is known as the Avogadro's constant. Is known as the Avogadro's constant. So there is a famous formula which states that the number of moles is given by the number of these elementary entities divided by the Avogadro's constant. The Avogadro's. So there is this formula that you will encounter in other books. Now, this basically means the same with this relationship that we have here. One mole of an atom is equal to 6.02 times 10 to the power 23. Well, we are saying this can be a representative of these elementary entities. So the 6.02 times 10 to the power 23 is a constant which can be a representative of atoms, particles, molecules, ions, electrons, protons, neutrons. So this number can be a representative of any of these elementary entities. What does this mean? So this simply means that if we are looking at one mole of an atom, this can be a representative of, this number can represent atoms. If you're looking at particles, this number can represent particles. If you're looking at molecules, this number can be molecules. If you're looking at electrons, this number can be electrons. If you're looking at neutrons, this number can be. So it's a constant. Therefore, it can represent any of the elementary entities that we have highlighted here. Let's look at a few examples on how we can find the number of moles using these elementary entities. So for you to find the number of moles, definitely you need Avogadro's constant, which is this number, and then you should be given a number of elementary entities. So this number can be particles, can be atoms, can be molecules, can be ions, can be electrons, can be protons, can be neutrons. So let's look at the examples and then see what we mean. So those are just a few steps that we can follow to find whatever that we're talking about. Now, my interest is we are looking at the examples given. Calculate the number of moles of each of the following: 0.5 times 10 to the power 23 molecules. So we're given the number of molecules, we're given the number of particles, we're given the number of ions. So when we go to the formula, if we decide to use this formula, number of moles is equal to number of elementary entities, then divided by Avogadro's constant. What number have we been given? So in the first question we are looking at, we are given 0.5 times 10 to the power 23 molecules. So we have been given molecules. Divided by, so the Avogadro's constant is 6.02 times 10 to the power 23. Now, what units are you going to incorporate? What units are you going to incorporate? So since we are dealing with these molecules, we say this will give us whatever we divide, there should be the number of molecules per mole. The number of molecules per mole, and whatever you get will be equal to the mole. Alternatively, we can go straight and use the relationship. So what does the relationship state? So the relationship states that one mole is equivalent or is equal to 6.02 times 10 times 10 to the power 23. So this constant number becomes molecules, because we're looking at molecules. Becomes molecules. Then you have been given, in the question you have been given 0.5 times 10 to the power 23 molecules times 10 to the power 23 molecules 23 molecules. Then you say x on the other side, because you don't know the number of moles, and those are the parameter of interest. So you cross multiply. So as you cross multiply, you know that this and this will cancel. So it's going to be x multiplied by 6.02 times 10 to the power 23, which will be equal to 0.5 times 10 to the power 23. So 0.5 is multiplying a one more. So you'll get the number of moles as your units. Then that will be divided by, let me try to scroll down, divided by So that will be divided by 6.02 and 6.02 on the other side. And what you get is the answer. So we can look at these examples here. So that is the working I was trying to demonstrate. So you state the relationship first, then you have the number of molecules, so you cross multiply, then you have x multiplied by that, and that will be divided by 6.02 throughout, so that your x becomes so that your x becomes okay, so that your x becomes 0.083 moles. So it is simple and straightforward. Whether you use the formula number of moles is equal to this number divided by the Avogadro's constant, it will still be the same. So on top you have the molecules as the units. If you're looking at the molecules, you have the molecules. Then at the bottom you have the molecules, the molecules, the molecules per mole, and you still get the same answer. So the units will be this and this will cancel. Now there is a challenge on when it comes to punching on the calculator. I have noticed that this has been a challenge. So when you're punching these numbers on the calculator, ensure that you observe the board mass. Ensure that you observe the board mass. So there are two ways of getting to the answer. Ensure that you observe the board mass. So when you're punching this number, this is how you're going to punch it on the calculator. So you say open bracket 0.5 times 10. So on the calculator, you're using a calcio, you find this symbol. So raised to the power, then you punch 23. Then you say close bracket, then divide open bracket 6.02 times 10, so raised to the power 23, then you close bracket, then definitely it will give you 0.083 moles. If your calculator is in standard form, this will be 8.3 times 10 to the power negative 2. Moles. So it's just a matter of knowing how to play around those numbers on the calculator, but make sure that you observe the board mass, and you get the correct answer. The other way is using the laws of indices. So if we're going to use the law of indices, we are going to divide this number and this number. If you're using the law of indices, so it's going to be 0.5 divided by 6.02. So you are at liberty to use this rule as well. So if we are dealing with the same base, what is the rule according to the indices? So same bases, we subtract the powers. So it's going to be 23 So whatever you get here will be multiplied by 10 raised to the power. So 23 minus 3, so will be 0. And according to the rules of indices, anything raised to the power 0 is 1. So that is another method that you can use and still get the correct answer. You can scroll down and look at the other examples. So that was example number 1. Example number 2, we were given 2.6. We were given to find the number of moles that can contain 2.6 10 raised to the power 46 particles. So if we're dealing with particles, it means that your Avogadro number becomes particles. So it's just one more is equal to 6.02 times 10 to the power 23 particles. Then what about 2.6? So you cross multiply there. So it will be 6.02 times 10 to the power 23x divided. So you divide throughout by this number, then you get 4.32 times 10 to the power 22 moles. If you're not comfortable with this relationship, you can say number of moles is equal to 10 divided by Avogadro constant. So your number of moles will be equal to what number have we been given of that elementary entity. So we are given 2.6 times 10 to the power 46 particles. So particles. Make sure that you're very consistent with the units, like we always say. More concept is about units. So divided by 6.02 times 10 to the power 23 particles. So these are particles per mole. Particles. So that the particles and the particles will cancel, and it will still give you 4.32 times 10 to the power 10 to the power 22. So whichever method you decide to use, you still get the same answer. So what is important is, how do you punch this on the calculator? So like I said, if you're punching on the calculator, open bracket, the number, close bracket, divide by, open bracket, the Avogadro's number, then close bracket. That's the correct answer. Or you can use the law of indices. So if you're using the law of indices, you say 2.6 divided by 6.02 separately, then times, so same base. When you're dividing, you subtract the bases. So when you're subtracting the bases, this will be 46 minus 20. So whatever you get there will be multiplied by 10, 46 minus 20. So more. So whichever method you decide to go for, you still get the same answer. So what is important is which formula you're comfortable with. So if you're comfortable with this, there's no problem. But if you're comfortable with the relationship of just stating one more is equal to 6.02 10 this will help us to determine what we call elementary entities. So these numbers can mean this number can represent protons, electrons, neutrons, it can be the molecules, it can be particles, it can be atoms, it can be ions. So always remember this relationship when we are talking about the elementary entities. So those examples that were given, this is how we get the number of moles. This is how we get the number of moles. Sometimes you can be given the number of moles and asked to find the elementary entity, like in the example that we have right here. Right here, calculate the number of elementary entities. So how many molecules can be found in 0.5? So it's simple and straightforward. State the relationship first. So one mole contains these molecules. What about 0.5? Then you just cross multiply. Or if you're not comfortable, you can say number of moles is equal to n then divided by Avogadro's constant. So you're looking for the number of molecules. So you say 1, you cross multiply. So the number of molecules will be equal to number of moles times the Avogadro's constant. So number of moles given is 0.5 moles times what is the Avogadro's constant? So 6.02 times 10 to the power 23. So we are dealing with molecules. So this will be molecules. This will be molecules, molecules, molecules per mole. Molecules per mole. So that the mole and mole will cancel. When you multiply, whatever you get when you punch will be the number of molecules. So it's just a manipulation. Once you know this formula, then you can manipulate and find whatever you're looking for. You can find the number of moles, you can find the number of elementary entities. So what is important is knowing how to manipulate the formula based on what is given. So here we found the number of moles by just multiplying and we get number of molecules. Uh, we are looking for a number of electrons that can be found in 3.4 moles. So the number of electrons that can be found in 3.4 moles. So the first thing is it's the relationship. So 1 mole is equivalent to that. What about 3.4? So basically that is how we determine the number of elementary entities using the number of moles or finding the number of moles using the elementary entities. So what is important is take note of the relationship, know the Avogadro's constant, and then use it to find the number of moles. So this has been the discussion for today. If you have any questions, feel free to slot them in the comment section and they will be attended to. So this has been your host, Mr. Manson. See you next time.